Here I'm asked to sketch a graph of the polynomial function p of x, stating the intercepts and end behavior. So I'll start with the x-intercepts because those are usually the easiest. Because this one is x minus 2, I know I have an intercept at x equals positive 2. And since this one is x plus 2, I have an intercept at x equals negative 2. At positive 2, it's a double root, meaning it's going to bounce off or it's going to have that parabola look. Whereas at negative 2, it's power of 3, meaning it's going to swoop on through kind of like a cubic function. So it's positive and looks like a power of 5. So that means that my end behavior should kind of look like this, where I'm going up at the end there, but they go in opposite directions because it's an odd degree. So what that means for end behavior, I'm going to kind of start backwards here. As x goes towards negative infinity, y also goes towards negative infinity because it's going down on the left side. As x goes towards positive infinity, y goes towards positive infinity because it's going up as we go to the right. So from this here, I'm going to come up to the negative piece, and that is where it is a cubic or a swoop there. The last thing that I need to do for my graph here is find the y-intercept, because for y-intercepts, I need to actually plug in 0. So I'm going to get negative 2 squared and 2 to the power of 3. That's going to be 1/4 times 4 times 8, which ends up just giving me 8. So I'm going to go all the way up here on my graph. Oops, I'm going to come through that and then down. And then it's going to bounce off of that point there because that's the power of 2. And so there is my sketch of my graph with my intercepts, my x-intercepts, my y-intercept, and then my end behaviors right here.